Please have a huge applause for Juri Strumpflohner. He is director of developer experience in Narrow, and he is Google developer expert for Angular. And he will present his talk, Architecting Large-Scale Angular Apps with Module Federation. And another thing that I would like to remember you is to rate talks on Joined-in. It's really useful for us and for our speakers too. And if Juri, you are ready, I will let you the stage. Thank you very much.
Thanks. All right. Tired? One thing to go, and then we can go to lunch and relax. It's really great to be again back in person. This is the first in-person conference speaking after COVID. Like there's always like a before and after, right? So it's really cool. Totally different experience obviously than online. So today I wanted to talk a bit about architecting large-scale applications, large-scale Angular applications. And as Shmela already kind of anticipated, we're going to look into how module federation can be a solution for that, and how we can kind of handle those large-scale applications. First of all, who am I? My name is Juri Strumpflohner. I'm a Google developer expert in Webpack and Angular, Cypress ambassador, and also an ACAD instructor. Currently, I'm working as the director of developer experience at Nowell. We are the company behind NX, so we kind of created that. We're doing also a lot of consultancy for some of the biggest companies in the world, Angular, but React. But the main topic is definitely tooling and monorepo. Most recently, we also took over stewardship of Lerna. Lerna is another very popular, kind of older monorepo solution for the JavaScript ecosystem. It was kind of obsolete, and we decided to take it over because we have a lot of competence in that area. And so we said, like, why let it die? Let's help and like go forward with that. And yeah, thanks for that. People are really enjoying that, and I really appreciated that step. All right, but today, a lot of the times you will hear about NX. We already heard about NX, which is great. So a lot of things will be like revising again, you know, like spaced repetition, right? So we kind of get into the flow. So next we'll kind of follow us through the talk because it's one solution of how you can scale such an architecture. NX is super popular. We're super happy about that, specifically in 2022, like this year basically kind of skyrocketed. So we hit like the 1 million downloads in January. In June, we hit like 2 million, and now we're heading towards 2.7 million. And so really happy about that, seeing that the community adopts it, that we get good feedback, a lot of usage. We also surpassed Angular CLI, which we're not competing, but it's a very important milestone for us as well internally, because as many of us, as of you know, we have first-class experience for Angular. We kind of came out of the Angular CLI, so we started as an extension. So it's a good kind of measurement for us of how much people adopt us and how much they like us in Angular. But let's talk about software architecture. Now, the term in general is really hard to narrow down, right? Because software architecture is like a vast topic, like it has a lot of different concepts in it. And I try to narrow it down to those three pieces, which is maintainability aspect, the flexibility aspect of an architecture, but also the scalability aspect. And I wanted to go a bit mostly today into the scalability aspect of things. And when we talk about scalability, the first thing that comes to mind is always like runtime scalability, right? So how do I deploy my app? Do I need something like edge computing because I want to be as near as possible to my users? Do I need to set it up in clusters where I can dynamically scale up and scale down? So that's the whole runtime and deployment aspect of the scalability. But one thing that is kind of often been overlooked is the development time scalability, right? So if I have large teams, how easy is it to allocate new teams to my application? How easy can I separate the development? What does the local development experience look like? Does it take minutes to serve my application, for instance, right? But also things like PR lead time, like how long does it take from opening a PR until it gets merged back into the mainstream line. So code organization, as you might think, is not like, you might think it's not that relevant, but it actually is quite relevant, right? When you want to scale in terms of the development. So this is a typical Angular CLI setup that you get out of the box. You can actually customize this, but this is what you get out of the box. And it is kind of, if you want monolithic structure where you have the features encapsulated in different folders, right? So these folders serve as your feature boundaries, where you then export and import stuff out of those boundaries. But like the problem that arises often, especially if you have large applications, like in this example is small, right? Just for the purpose of the demo, but like if you have large applications, you have like tons and tons of such features. So it's really hard to ensure those feature boundaries, right? What can a certain, in this case, folder export to the public? What is it intended to export? What can other people use and what they shouldn't use, right? So how do you keep control of that to not basically get into a messy situation? But also, how can I just run parts of that? So how can I just run the testing or linting form authentication part, because I'm not interested on the rest of it, because I, as a developer, just work on that specific feature. So those are all aspects that need to be added to development time. So what if I told you there's another way? And Luca already took it away today morning. This is the organization that we promote by default in NX. Again, you can completely customize it. You could still just take the AngularCL application one-to-one, copy it over into an NX workspace, and run it the same way. Would work. What we, however, promote is such a separation, where you have like an application at the top and you move all the logic into so-called well-defined workspace libraries. Now I call them workspace libraries because they don't need to be deployed to any NPM repository or anything. They're just local. They don't even need to be built separately. You can, but you don't need to. So the whole workspace, the whole development experience is exactly the same. You just basically allocate them into libraries and create better boundaries around them. And as you can imagine, this also helps then allocating teams, right? Because now I can say, well, there's a my account library, there's a checkout and products library. I can allocate teams into those subset of libraries. And here I have 3 of them, but I can obviously expand them as I need in those feature areas, in those domain areas. And I might as well have like more of an infrastructure team, which works like across the board, making sure that the whole application infrastructure is up to date, the whole like maybe shared design system is up to date. So those are usually components or libraries that are shared across various things in my application ecosystem. So we have the application, which is really just the deployable container in the end, where you pull in whatever that application needs to deploy, right, from those libs folders. And most of the code lives in those libs. How does it look like in terms of structure? This is an example workspace from an NX, equivalent example from what I had from the AngularCL before. So you see the apps folder at the top, and then you see those libs folders further down. And every of those libs folders has a perfect or a clear export path there, right? There's a kind of like a barrel file, like an index.ts file, which you have typically in libraries, where you export what is public and you keep inside the folder structure of that lib what it needs to be staying internally. So there's a clear contract in that. And that not only helps from a technical perspective to develop those, right? Because you have to think about actively what am I do I want others to share and what do I want to stay within that. How do you use those? You just import them, right? Like we can import them by the router. We could actually use techniques such as Mela has shown before, dynamic loading them, because it's really just a path. In this case, for instance, NX Megastore / checkout or my account, which points to that library that has an index.ts file, and that will be imported. So the whole experience is kind of very much the same. As mentioned before, the point is those give much stronger boundaries, and they can help me shape my application infrastructure and scale them across teams, because now every team is kind of responsible what do they share with other teams. There's even a step further you could go, right? And we see a lot of companies adopt, which is tagging, right? In NX, for instance, we have a system where now you have those libraries and you can give them tags. You can see this is like a type of a feature library. This is a utility library, so it is intended to be shared across feature libraries, right? While maybe one feature library should not be able to import from another feature library directly. And so these are tags that you can give, and then you can use specific lint rules that would automatically check those violations on your CI system or when you're running locally, right? So that's how you guarantee that your ecosystem evolves in a kind of coordinated manner, in organized manner, rather than getting like issues later on as you grow. There's actually a good blog post in this link here. It's on our main blog, where Miro, a coworker of mine, like goes into really the details of how you set it up, what are the advantages, and like how this can be configured. Again, the experience, what you have is exactly the same. If you wouldn't like switch out, let's say that you wouldn't even notice, right? That you structure underneath is actually quite different. Now, one issue that often comes up in scalability, right, is slow CI time, right? So if I have a large application, at some point, as I keep adding, it will kind of slow down on my system. This structure that we showed before actually not only helps us allocate teams, but it also helps us with the scalability aspect next time. Because now that we have separated the structure out of just pure folders into dedicated libraries, we can actually start doing optimization. And Luca kind of anticipated that already by mentioning the dependency graph, for instance, right? So in this case, if we change checkout, for instance, we can depends on the app, or the app basically depends on checkout. So those are the things that we need to validate if we change. So we run tests against like those two parts. We run linting, we run all the types, or even custom commands if you want to run against those. So we can already, you see, narrow down what we actually run. Obviously, if you have a more lower level library, them, right? But not necessarily in the entire ecosystem of all the libraries that we have. In Nnex, you use those effective commands. They again use the Git history of that specific PR, compare it like with the base graph of where the PR or the branch started, uses that graph to understand like, okay, which projects got touched in those different like files that got changed in those Git commits, and then runs simply the operations against those. And with that, you get a more performant running CI as well. But what I intentionally just talked about the testing and the linting here, because the build right now and also the local serve times are still just at the top level, right? So when you run the build of the application, there's Webpack, which runs one build for the entire part, right? Because as I mentioned before, we literally just like extracted things into libraries, but we didn't do anything else. Why is that? Well, you might wonder like, you can like Nnex megastore / my account, and it still works. The reason is there's a path config mapping, like a TypeScript path mapping at the root of the workspace, which simply says, well, this is like an alias that points to that entry file, right? And that's it. So Webpack, when it builds, it just walks path, right? It's a TypeScript feature, just includes everything into the main application build. So the issue is a single monolithic Webpack build. In a small application, even in a medium large application, this is not a big issue, right? So you can still continue, the effective commands do their job, so it's fast, and it wouldn't be an issue. But if you really scale to large workspace, this might become one. Have options, right? Having this structure already, now you can start like iteratively make optimization. One thing would be, well, let's make all those libraries buildable, right? So let's basically configure them that they each of them can be built separately with ngPackager in this case, we're in an Angular workspace. In Nnex, you can do that with a command where you just give it like a -- buildable flag when you generate the library. So it would be set up with an ngPackager build script. It is actually an optimized ngPackager build script because we don't intend to publish this library. We will just want to make it buildable, right? So we kind of cut out some stuff that is just used publishing steps to some npm registry. Now, how does this help, however, with build steps or build times, right? Because now we don't have a single build step, but actually we have like a ton of different build steps, right? So in theory, it's actually slow. The point is caching, right? Now that every piece is being built independently, an Nnex mechanism where when we run the build of one of those libraries, or in general a build or test or lint run in an Nnex workspace, Nnex takes the command. It takes like different aspects like runtime variables, the source code, some global configuration, even things contribute to that caching. It computes a hash and it stores it locally. And so whenever the same command reruns, battery sense. Can you hear me? Yeah, seems to work. All right. So basically, whenever a command runs, Nnex simply the second time compares it against the hash that it already has, and if it has it, it just restores it. Right? There's no need to rerun that same command again. So that means that now, if you run Nnex build shop at the very top, Nnex walks down the tree and can actually understand that it has already built some of those libraries, so those will be just restored. It will be super fast. The downsides of that is it has some overhead, of course, because we need to run ngPackager for each of those steps. We have optimized ngPackager, but it's not the fastest, I would say, in terms of like building part. So here's like actual some stats which are from 2 years ago, but they're kind of representative in terms of the distribution of the speed, right? Where the first one is just a normal build of Webpack, where we built everything, right? And it's kind of slow. So in this case, it took like over a minute. It's not a super large workspace. You can see the incremental build where I made everything buildable and with no cache at all. It is actually slower, which is reasonable, right? Because now we're running not just one build, but we're running like 50, 100 builds, right, of all those packages. But you can clearly see, like, if we have a cache, how much faster it is, right? Like, it's super fast, right? It's 7 seconds compared to like over a minute, right? So that's kind of the downside if you don't have cache. There's one issue still, though, which is the Webpack linking time. In an X specifically, when an X detects that the library is buildable, it automatically is smart enough basically to first just build the library that gets produced at this folder, and then an X automatically relinks the Webpack file to the this folder rather than the source code. So you actually don't have to change anything of that. That's what happens behind the scenes. But if you have large workspaces, we have seen with some of those big companies that we work with, Webpack, the linking time alone can take a substantial time, right? Really long time. And even the serving time. There are apps where like you run ng-serve and it takes like 5 minutes to show it in the browser, right? And that obviously you can imagine like that's kind of a pain to develop again. So the reason, like what can you do? Keep splitting, right? Because when you split, we can actually then cache the subparts and then we can basically optimize again our time, not just like local serve time or build time, but also on our CI. Solution, what I call like vertical slicing. So the horizontal slicing, that was basically what we have seen here, where you basically slice the layers in this case, right? Per library, you make them buildable. The vertical slicing is what I call when we split up the application, right? So we don't just have one single application, but we split it up into domain areas, which most of the time already reflect our library structure underneath. So in this case, for instance, I went ahead and said like, well, we have like a my account sub application, we have a checkout and products application. Those are independent. And this is actually very useful because many times we also hear like teams saying, well, I'm just working on that my account or product page. I don't care about the rest. So I don't want to like take, if like the my account or checkout is super slow, I kind of have to take that burden on just to show my products page where I need to debug something, right? So now you can actually slice them and load individually. The point is now the vertical slicing happens this way because you can use the dependency graph or in an X specific to just take everything that my account uses and build that into one bundle, everything that the checkout uses and everything that the product uses. And for the libraries like authentication UI, you could still make them buildable and then like cross both approaches, right? Where they are used across all those 3 applications. So it might make sense to make them even buildable so you get more caching even out of that. Again, very important, especially for us at the Next team, the developer experience is exactly the same. You still run npx nx shop and you get all applications running. So from like a developer point of view, you don't notice a whole lot, right? Even though those applications are built dependently. But they are now cacheable, right? So if I work on my products page, my products app, my account and checkout can just be pulled out of the cache if someone else has already built and run that before. Another part is also then, those things are cached statically, so meaning we don't even run Webpack, right? We just like use a local static HTTP server to show your web page, but it's from static pre-built files. While obviously if you need to develop a product on the product part, for instance, you want to have the same experience. You want to have like fast reloads, dynamic reloads when you change a file and all that stuff. So you can actually now with like something, for instance, like a flag of def remotes, pass in and say, I want to work on products. Maybe you can even add another one. Those then would be used with the serving of using Webpack, while the others would just be served statically and be pulled out of the cache. How can we do that? Model federation is one approach to do that because it gives us the instruments to actually build those applications separately and still integrate everything into one part. So model federation at the super high level, and don't go into details like too much today because like that would open up a whole other talk basically. But as we have heard a couple of times, Manfred Steyer is really on top of those things. We actually actively collaborate with him as well. Like he has a lot of resources to actually go deeper in the model federation part and how it works. But at a very high level, it's kind of, you can load in a separately compiled code, but using Webpack, for instance, Webpack at compile time kind of knows already how the situation looks like and can therefore kind of do some pre-arrangements such that that dynamic loading then happens without issues once we deploy our application. So usually what you're talking about in that context is you have like a shell, which is basically your application, in our case our shop, right, our shop app. And then you have different pieces that you load in dynamically over that Webpack model federation, which is like, in this case, have remote 1, remote 2, remote 3, which are basically our applications. So are we talking about micro front ends? Today, not really in my talk, like we will see why. But Webpack modification is very often used for realizing micro frontends, right? Because this scenario is more or less, you could kind of write a title micro frontends on top of it, it would work, right? Because you have the challenge, you integrate dynamically pieces from various sources at runtime, even completely dynamic. What we want today, however, is just that slicing aspect of the Webpack modification, right? So we really just want to gain a speed aspect, also because realizing and deploying independently has an overhead as well, right? So if you deploy a micro front end, you have to deal with version conflict, like version backwards compatibility, shared aspect. So that is additional complexity, which a lot of times we talk to is not necessarily what they want. Like the first thing they mention is like, yeah, I want a micro front end, but then if you dig deeper, it's like, well, actually, we want just faster builds. Micro front ends can help us with that, right? So there's like multiple steps you can go this way. And the nice thing is you can do it incrementally, right? So we can now just split it. But at some point we were like, oh, we want to deploy independently. Well, it's just an additional small step, and you have the micro front end part as well. One thing we do in NX, and this is kind of what we inherited from the Angular CLI, and you can see our connection to that here as well, is like we have generators for most of that stuff, right? So we want to make the developer experience really great by providing a generator that sets you up this out of the box, right? So in this case, for instance, you can run here NX generate novel Angular post, which is like our shop, and then you can give it all the remotes that you want to generate, and it would already pre-set up that for you, such that then you can just run surf and it works, right, under the hood. And that is an interesting scenario, but I think like most people are in this one, where they're like, oh, we have our Angular app, maybe an Angular CLI or NX. It's super large now. Build times are so slow. We want to do something about it, right? So you're usually in that migration part, and we have commands for that as well. So you run on an existing app setup -mf for modification, and you give it like what type it is. So it would just set that up, and then you can generate remotes for it dynamically, right? By saying, okay, this is a new remote. My host is the shop application, so it kind of knows the connection and it knows how to configure those two aspects. Again, same experience, right? You run NX surf and it works. Let me actually show you how that works just at a high level in an actual NX workspace. Let me actually, I think this might work better, right? All right, so here we have an application, and one of the first things that I usually do is like run NX graph, just to show how does that look like. Let me see where the graph is here. So this is our application structure in this workspace, right? We can maybe even hide the end-to-end tests because we don't really need them right now. But you can see here we have the shop application at the very top. It's exactly the situation which I kind of talked about before. And you have those various remotes, which are kind of just like as a middle layer, right, for those libraries down below. And then they connect to those libraries. How does this look like in the code base itself, or how do we use it? Which is the following. So if we go inside here, for instance, in our shop app, and I go here into that module, so Luca has shown this already today morning, where you load in your libraries lazily, right, which live like in the libs folder. So here I have my checkout and so on, which you load in from that libs folder down here, where the actual logic exists, right? Now in this case, you might notice I don't really load in the library, but I load in that intermediate part, which is my remote module, right, which we generated, for which we created. And here, for instance, the checkout module is just a separate application up here, right? Now I have them all flat, just because it's easier to look at. I would suggest create subfolders. You can totally do that, right? So it kind of collapses and it's more nicely organized. But what happens inside here is this is a modification remote setup. You see a couple of configuration here where it says what it exposes, which is here the entry module. There is the Webpack config, which is very simple. So we wrap it with like a function that we export from our now plugin, our Angular plugin. We load that local modification config, is this one here, right? And then we just re-export it such that like the Webpack modification can pick it up and knows what is going on. So here's the place where you could mess around more, right? Like where you might want to configure it like differently. But this is what you get generated. So in theory, you don't even have to worry in the normal case about this file, but it's there because it's important. And then if we go into the interesting part, we go into that remote entry module, right, which is the one that is exposed. And here actually then we load our library, right? So it's kind of like a bridge, an addition that you have in between your loading of the library. But now we have different applications in there. So if I run this, as I mentioned before, I just run nx surf shop, right? And it would just now rebuild all the different things. Now here is a situation where I have a cold build. I don't have any cache, right? So it runs the builds of all the sub applications automatically. And then last step, it will serve up our final application, which then runs on the 4200. Looks like almost as I coordinated with Luca in terms of the type of application, seems a common example. So here you have now those different parts, and those are actually different applications. So I could actually go here and go to 01, and this is the checkout application, right, that runs. So there's like 3 servers in the background that kind of are automatically spun up by NX and then closed down again. Advantage, of course, if I rerun this, it's super fast because everything gets out of the cache, and it just builds the shop app, which is the shell container, and I have it already running, right? So that is the main advantage that you gain out of this. Let's go back here. So this cache, as we have seen here, is local by default. So meaning every NX installation gets it locally set up. So you get that for free. But obviously, the real value you get out of it is like when you share it, when you distribute it, right? So you have your coworkers on their machine, which contribute to a central position basically where that local cache being synchronized, as well as your CI system. Like the CI system is one that, first of all, consumes a lot of cache hits, but produces a lot of cache hits, right? Because like our PRs are constantly running. We might have nightly builds and everything, and so those help tremendously to speed up things. We do that with NX Cloud. That is our cloud system where we kind of synchronize all those different cache locations. If you haven't tried it, try it out. It is it comes with 500 hours free of computation per month, which we kind of looked at our stats, and that is more than enough that you need for most companies actually, for small, medium-sized ones. And if you go over, what happens is like the worst case just stops caching. There's no kind of large bill that you get at some point, like billing you for cache hits. If you're a company and you're interested in having it on site because you cannot, for privacy reasons, host it in the cloud, we have actually a setup of NX that you can install on premise inside a Kubernetes cluster and everything. Like we looked, did quite some investigation to make that work. And we see tremendous savings that we get out of NX Cloud. We just looked at the stats, I think 2 weeks ago, and like in a week, we just on a public cloud, we save around 5 years of computation time. In a month, over 25 years. So you can imagine how much that is. And we have even private cloud installations from some large customers that save in a week 1.5 years of caching, just in a week, right? And this translates actually to like environmental savings as well, right? Like the less computation we run, the less we kind of hurt the environment. So it's a good thing as well. So one aspect you might think of now is like, well, I don't have that super large, massive application, so do I really need it? I would say you don't have it yet, right? But as you evolve, it actually gets bigger. So the flexibility aspect of the whole software architecture is actually important, right? So to have a structure which kind of works with you as you have a small application, and then you can, however, incrementally adopt it and expand it as you need it. So I would never suggest to anyone like go full in on this kind of setup with modification, splitting apps, because it comes with a small overhead, right? We tried hard to make it like as user-friendly, as developer-friendly as possible, but it comes with an overhead. So the thing is like start small, even if like you have a single application, but by having this structure, it actually opens up to actually create multiple applications, create such a modification setup, because it's very easy, right? If you remember, you have just a small thin application layer at the top, linking a different library into a new application is actually just a couple lines of code and you pull it in and you deploy it separately, right? So the point here is like about opening opportunities of expanding in the future your application code. So to recap, at a very high level is like by splitting things into smaller units, in this case, for instance, libraries, you get like it's much easier to allocate people, right? Because like you can distribute them much nicer. You have a lot of opportunities there to speed up things just because now you can run them locally just for a certain library and not the whole application always again. Webpack modification is not just for micro frontends, right? So what we did is we were like a step before having a micro frontend, right? Because we deploy it as a whole still, but you could just configure that micro frontend, like that Webpack modification setup in a slightly different way, and you could just deploy things independently and load them dynamically. What about if Angular goes to ES build? Like, we're super excited about that, but there's no Webpack anymore, right? There's actually good news because Manfred, for instance, Manfred Steyer, which I mentioned before, he's looking into native modification, which goes over native browser APIs, right? There's a lot of other initiatives that come up in that case. We closely collaborate with Manfred, as well as Zach Jackson, which is like the founder of, the creator of Webpack modification, to kind of be there also, like Angular hopefully goes ES build at some point forward, because like you want to benefit from that speed, right? But there are ways to have such a modification setup even outside of Webpack. And yeah, finally, NX provides kind of that strong DX, and we kind of like put a lot of effort into that to make sure it is as usable as possible and as simple as possible. So our goal is really to grow alongside, right? To not basically be a big drop in and then it's hard to get started, and just grow as your application grows. Some of those videos have already been cited today, which is awesome. Spread the word. We currently look a lot into like creating visual content on YouTube. Usually those are even paired with like a blog article for those that prefer like reading alongside. So the goal here is the first one actually does mostly what I have done today. So it takes an existing Angular app, splits it up, and slowly uses all those generation to come to a modification setup. The others are migration scenarios if you want to migrate over, right? So we are very attached to the Angular ecosystem, and we want to help it move forward and grow, right? So we want to provide an easy integration as well. The first one is really super easy because it's like one command. Most people are in the second one. It's a bit more effort, but I tried my best to help you walk through the different steps there. Last but not least, shameless plug on my side, we have NXConf coming up. If you want to travel to Arizona, definitely do it. Tickets are running out, but it might be a bit late. We're also streaming live online for free. And the only thing is you need a ticket, right? Even for online attendance, make sure you go to nx.dev/conf, get your ticket, and then you can follow along online because we wanted to open it for as many as possible. Yeah, and if else, follow us online or our Twitter channel. That's where usually we push out new news. Small hint, Learner 6 is coming out probably next week, and NX 15 is just around the corner. So have an eye on that. And if you have any questions, even afterwards, feel free to approach me. I'm happy to answer in German, Italian, and English. So, but that's kind of it. Nothing more. But yeah, would love to chat. Thanks.
Thank you very much, Juri. Are there any questions? Yeah.
Thank you very much. Yeah, I have a question about the organization of the application. I mean, when you show the shop, you show that we have the shop application, the main, and you have like sub application. But in a folder organization, they were in the same at the same level. There is a way to organize between subfolders, for example, because I'm imagine a case in which you have more application and different application, very different between them. So
Absolutely, absolutely. Yeah, this is mostly the setup here is mostly for simplicity, right? But like what you can do is, for instance, if you generate a new library, and I'm using here NX Console, for instance, to generate a new Angular library. What you do is like say a right? You can actually give it a folder down here where you say my custom feature, right? And so when you run this, it would nest it under a subfolder, right? So you can see here my custom feature, and then there's ngday underneath there, right? JSday, and there will be another feature under there, right? And so this is usually also the way you see applications being structured. So the folder at the top is the entry level of your domain area, let's say, and then you have multiple libraries underneath, right? Because you might have like different features for that domain area, of course. Like the products page usually might have a library for the product list, another one for the product detail, might be a separate library completely. And what you often see also is like even an API library inside that specific folder structure, which is the one intended for other feature domain areas to interact with. So you have even like a dedicated export point there. Again, there I haven't leaked unfortunately it here, but Manfred Steyer has a book on, I think it's called Angular Enterprise Architecture or something like that, where he actually uses NX and talks a lot about domain-driven design, how you kind of structure the domain according to your areas, how you can actually reflect that in such a structure of an NX workspace with libraries. So definitely use subfolders heavily, right? You don't want to, even for the applications up here, this can obviously not scale, right? Otherwise, you have like 100 applications up here, it doesn't work, right? So can nest them.
So the same can be done with the apps folder?
Yeah. In theory, even the entire folder structure, so even the folder that effect that is called apps and libs is completely customizable. So you can go into the NX.json and just change how you want to call them, right? Or even just have one folder if you prefer for some reason. So it's completely flexible. This is more or less like what we propose as a starting point, but you can completely reorganize as you prefer.
Thank you very much. What is the correct way for
So
buildable library? What is
yeah,
the correct way?
yeah. So in the workspace here, you don't actually publish anything, even if it's a buildable library. That's just for the purpose of splitting and being able to cache that build separately, right? If you have, however, and that is very common, right? For instance, if you have a monorepo where you have your shared design system, which you use in a monorepo, but that shared design system, you also want to export it, right? I mean, most companies that I've worked with right now, they are not in the Google case where there's one monorepo, but there's like multiple monorepos, and so there's still the necessity of publishing and sharing across those, right? And so in that case, you make that library publishable, right? In that case, you can then, with ngPackage and Angular, you can just version it. The versioning scheme itself is something that you completely control on your own, in the sense that you will have a package JSON, you can set up like a custom script or something to increase that, but most people there follow then the semantic versioning, and you just publish it out of the monorepo, right? However you want to automate that really kind of depends on your situation, whether it's something that you trigger or you even do it in an affected publish step, which you could hook up, right? And you run it as part of your CD pipeline. That is kind of what you figure out. But there's the versioning aspect in general is not something an X goes too much into the detail. It just gives you the package JSON, just as ngPackager would do, right? And you kind of tune it there and use it there.
Any other question? Yes.
Thank you. So it does make sense to have a single directory in the libs with all the data model. For example, if I have an interface for the user that could be shared across all the application, does make sense. Or if I change, because at the end during the build, if I change that interface, all the other projects needs to be rebuilt.
Yeah. It's a good question. It's a tough one because that very much goes into how you architect your application, like your system in general, right? It's very tempting. Like it's very tempting to just create one library that calls your whole user models, right? And you share with everything. The point is, you correctly pointed out, is then when I change the user model, everything gets changed, everything gets affected. I end up like again with slow builds, right? So it's kind of, from my perspective, is what we kind of tell people is like it depends on, like you have two focuses basically. One is like splitting according to basically for optimize for build speed, right? Such that like you get as most out of those affected and caching as possible, right? But at the same time, if you have a single, from an architectural point of view, if you have a single model that is shared everything, that also creates coupling, right? Which the build step just reflects in the end. So what we, like when you go more into the domain-driven design where you have like a per feature area, what often happens is that you start not just having one global object, but you start like having local objects per feature area, such that you decouple them, and then you have maybe just integration points on those API libraries, right? The downside of that, again, like, there's always trade-offs, right, in software development. The downside of that is you have a mapping layer somewhere, right, where it translates between one model or the next, right? So it really takes, like, it really depends on how you want to cut the boundaries and also how much trade-offs you want to have, because maybe it's fine to have that shared library up until a certain size, right, and then at some point you need to refactor and kind of move it out and split it up. So there's no real rule that you can give for like structure or cutting, because it really depends on the architecture. Something I mentioned before as well is like what you can look at is even like in terms of saying like how many libraries do I want to have or how few libraries do I want to have, is look at the speed of how they change over time, right? Because if you see that you have a couple libraries and they always change at the same speed, so meaning whenever I touch this one, I also touch those other two, that's usually an indicator that those problems, they are very closely related, so maybe it's time to merge them, right? Rather than if I have a huge one which is slow to build, but I always just touch a local area of it, well, that's a good sign to extract it. So it's always something where you cannot give a clear rule, but you can just like observe it over time and then like see, okay, here you need to adjust, right? That's also why my perspective, like software architecture is something that evolves over time. It's not something that you can stamp and this is how it would go, right? But it's something that you continuously need to look at, refactor, and like kind of maintain over time. And it's very specific to your workspace as well.
Ah,
I'm a bit interested on this, on module federation, and my question is, could it be useful to have different libraries with different framework, like Angular, React, or Vue, for example?
Yeah.
Well, what's your opinion?
What I see is that people try to avoid it. The thing is, like, if you go full modern federation, like really at large scale, like not modern federation, micro front ends, right? Then you might end up in that situation where you have like you pull in different widgets from different sites. One might be a team that develops it in React. Let's take the Amazon website, right? There's like the checkout button, which is like a completely different team. You don't even know them maybe, right? But they're on the same page where your stuff runs. It comes with a lot of complexity. So usually what I see, people try to avoid it. They try to stay within the same technology part. And what I see often is also like separate over the routing. It's much easier and instead of like embedding it in the same page, right, as widget, because that runs on the same browser window, meaning that additional JavaScript gets pulled in. You cannot like leverage like in the sense if you have like an Angular app and a React app running, you have both frameworks loaded. You need to, right? There's no way to kind of get rid of that. So if you can at least like separate it via routing, so you could have like the high level structure, maybe the entry page is created with, I don't know, Angular or whatever, right? And then you have the different routing points, and then the sub pages are in different frameworks. That might be easier. And there you could actually, the monorepo can help you because like maybe some aspects you can share, which you can create in a more like framework agnostic way, right? Maybe you use pure web components that you have in the monorepo and then share in the libraries and deploy them with that, right? So that can be a way to do it, but like most of the time I see people avoid it. How also a lot of people avoid just going the full route to micro frontends because it has the complexity. If you have the team and is capable of, and that's the situation you are in, that's perfect, right? Like you're glad to have that technology that makes it so easy nowadays, right? But it has additional complexity of versioning and separate deployment, coordination, and that stuff.
anyone else? No? So thank
Let's
you
go
again
lunch.
very much, Juri.
Thank you.